All right, what we're working with today is equations of parallel and perpendicular lines. The first thing we need to know is what parallel lines look like. Parallel lines are lines that never intersect. And so one goes this way and the other one goes the same way. So they're never going to intersect. The symbol for parallel lines is just, it looks like an 11, but it's just two straight lines. When you have parallel lines, what happens is you have the same slope. So I go up 1 and I go over 2. Up 1, over 2. So they have the same rise over run. So their slopes are equal. Perpendicular lines, remember perpendicular lines are lines that look like this, and they form a right angle right here. So lines that make 4 right angles. The symbol for perpendicular is actually an upside down T. And with perpendicular slope, what happens is they are the negative reciprocal. And so what that means is if my original slope is 2/3, my perpendicular slope is negative reciprocal, which is just flipping it. So there's a little kind of song that helps you remember it, and it says parallel slopes stay the same, perpendicular flip and change. Parallel slopes stay the same, perpendicular flip and change. So that kind of helps you remember the rule, and so we'll go to that song occasionally. So I need to determine if my lines are parallel, perpendicular, not related. Well, the first thing I need to do is I need to do my slope formula. We've spent a lot of time with slope formula, so let's leave that there. And so we have two lines. We have line A, and then we have line B. And so A is 2, 5 and negative 2, 7. So remember it's x1, y1, x2, y2. And then it's the same thing on the other one. x1, y1, x2, y2. And so now, where am I at? I'm going to change colors and do the work in a different color. So it says y2 minus y1, so it's going to be 7 minus 5 over x2, negative 2, minus 2. So that's 2 over negative 4, and that 2 over negative 4 reduces to negative 1/2. And so now let's change color so we could see the other one. Same idea. y2 is 6 minus y1, 4, over x2, 1 minus 0. So that's 2 over 1. So this slope, oops, I didn't mean to write perpendicular. This slope is 2 over 1. So the first question is, are they parallel? Well, parallel slopes stay the same. These two slopes are not the same, so it's not parallel. Perpendicular, you flip it and you change it. And if you notice, 1/2 flipped is 2 over 1, and it changes signs. So these two lines are perpendicular to each other. So the next example is when we have a linear equation. And so this one is easy to find because remember it's just y equals mx plus b. And my m is attached to x. So for the first one, my m is just 1/2 because it's right here. It's attached to the x. On the second one, I have to do a little bit more work because I'm going to have to get y by itself. So remember, you would add x to both sides. And so I get 2y is equal to negative 3 plus a 1x. But now I have to divide everything by 2. And so I get negative 3 over 2 plus 1/2 x. And so for this one, my m is attached to the x, so my m is 1/2. Well, those two things are the same, so that means that they're parallel. And I'll write that word too so that you can see. So the problem on the left was parallel, the problem on the right is, the problem on the left was perpendicular, the problem on the right was parallel. So this is the main idea of this whole section, is just figuring out if things are parallel, perpendicular. We will do some other stuff with it towards the end, but this is the main thing right now. So what I have is I have some examples I'd like you to try. I would like you to try number 1 and number 2. Go ahead and write them down, and when you think you're ready, press play. Okay, so the first thing you should have done was labeled x1 and y1. And then again, I'm going to use my slope formula, which is y2 over y1 minus x2 over x1. So for line A, I get 4 minus 2 over 5 minus 1, which is 2 over 4, which reduces to 1/2. Now I need to do the same thing for line B to find my slope. So 4 minus 3, 2 minus 0, which is also 1/2. These two slopes are equal, so that means that these lines are parallel. Okay. All right. Okay, so again, you have to find the slope of all three lines, and so it's going to be -6 minus 5 over 3 minus 0, which is -11 over 3. 0 minus -2 over 3 minus -3. So those will become plus, which becomes 2 over 6, which reduces to 1/3. And then 3 minus 1 over -3 minus 3 is 2 over -6, which is -1/3. And so I'm going to go back and I'm going to highlight. I have -11 over 3, 1 over 3, and -1 over 3. And so to determine which ones are parallel, so parallel slopes stay the same. And so if you notice, if it's any of them, it could be these two, right? Because they're the same numbers. But if you notice, this one has a negative. So in order to be parallel, they both have to be the same. So they're either both positive or they're both negative. But because they're different signs, none of them are parallel. So for number 3, you're going to do the same thing as number 2. You're going to set up by finding the slope of each, and then we're going to discuss which ones are perpendicular. Okay, so when we start off by doing this one, let's change color pens. So again, I have to find the slope of each one, so it's 2 minus -2 over 6 minus -2. So that becomes 4 over 8, which reduces to 1/2. And then I'm going to do -1 minus 5, -2 minus 1. So that's a -6 over -3, which becomes a +2. And then I'm going to do -1 minus 1, 4 minus 0. And so that's -2 over 4, which is -1/2. So let's highlight the different slopes. And let's see which ones are perpendicular. Now remember, perpendicular you flip and change. So they have to have different signs. So it can be line C with line B or line C with line A. And so I got to focus on this. So if I change the sign, it becomes positive, but if I flip it, it becomes 2 over 1. And look, that's this one right here. So those are the two that are perpendicular. So what you say is you're going to say B is perpendicular to C. And that's how you write that answer. All right, for number 4, you're going to go ahead and solve for y on both of them, like we did right here on line B. And then once you solve for y on both of them, then you're going to find out if they're parallel, perpendicular, related by looking at the slopes. So I moved over the line A so I had some space. So I get negative y is equal to negative 6 minus 2x. Can't forget that negative. And now I divide everything by negative 1. And so I get 6 plus 2x. So for this one, my m is 2. Because remember, your m is always attached to the x. Now I need to do this one. I'm going to minus 2x on both sides. And I get y is equal to negative 3 minus 2x. And for this one, my m is negative 2. So I'm going to look at my slopes. I have a negative 2 slope and a positive 2 slope. Parallel slopes stay the same. Well, they're close to being the same, but they're different numbers, so are different signs, so they're not parallel. Perpendicular, flip, and change. So they're changed, but they're not flipped. So these are actually not related. Oops. I believe I missed that circle. There we go. Okay. All right, the last two are, this is the only type that's really different, and we're going to use our point slope formula, which is the y minus y1 equals m x minus x1. And remember, what's important is you plug in the y1, the m, and the x1. So let's look at number 5. For number 5, my slope is supposed to be parallel to 1/2. So parallel slopes stay the same. So my slope is 1/2, and my point is 4, negative 7. Remember that this is x1 and y1, so now I'm going to plug it into this equation right here. So it'll be y minus my y1 value of negative 7 equals my slope, 1/2, x minus my x1, which is 4. So right here, those become a plus 7. And now I have to distribute. 1/2 times x is 1/2 x. 1/2 times 4 is 2. And then I get rid of a plus 7 by minusing 7. And so my answer is 1/2 x minus 9. But the only thing I had to do first was look at what was parallel. Okay, so this one says perpendicular. So that's the type that we're going to have to change. So for number 6, my slope, I have to flip this and change it so it becomes negative. So really, negative 3 divided by 1 is just negative 3. And the point I'm using is negative 2, 1. So now I'm going to use my formula right there. So it'll be y minus x1, y1, 1 equals my slope, the one that I flipped and changed. So negative 3 and x minus negative 2. So I get y minus 1. These two become plus. So negative 3 times x is negative 3x. And negative 3 times a positive 2 is negative 6. And now I'm going to add 1 to both sides. So I get y is equal to negative 3x minus 5. So the biggest thing for parallel and perpendicular is just to remember parallel slopes stay the same, perpendicular flip and change. And you have to be able to find your slope from the slope formula or from an equation.